Words cannot describe how thrilled I am. Actually, I've been waiting quite a while to say that. And what a privilege it is to introduce today's Saturday morning physics speaker, Professor of English Anne Curzan. As I said, I've been looking forward to this for several years, and we've been working on this event after Professor Curzan finished her term as the Dean of the College in LS&A, and now has been enjoying a well-earned sabbatical. We finally managed to merge schedules so that we can welcome Anne here today. And it may seem incongruous, actually, to bring scholarship of the English language to Saturday morning physics, but what better venue for such a celebrity among us detail-oriented intellectuals, I guess they're sometimes called nerds, than Saturday morning physics. Anne Curzan is the Geneva Smitherman Collegiate Professor of English and Linguistics and Education. She grew up in Montgomery County, Maryland, and after graduating from Yale, she came to the University of Michigan as a graduate student, and then spent a year at the University of Washington. Is that correct?
4 years.
Oh, 4 years. And then came back here to the University of Michigan. She was the Dean of the College of Literature, Sciences, and Arts from 2019 to 2024, and she's recognized as an exceptional educator and scholar, and by the University of Michigan, for example, as a Turnow Professor, the Henry Russell Award, and the Faculty Recognition Award, and the John Dewey Award for Teaching. So you're a member of the American Heritage Dictionary Usage Panel, and I used that actually to look up nerd. And the board of the Word of the Year society called the American Dialect Society. And with all that, you've written 6 books, and the most recent is That's What They Say, a kinder, gentler guide for everyone who cares about words. And wait, there's more, as you know. There's the weekly, as you may know, there's the weekly Michigan Public podcast and broadcast. So That's What They Say, that she hosts with Rebecca Hector. So, Professor Curzan, welcome to Saturday Morning Physics, and thank you for your presentation, When Physics Lost Its K and Other Linguistic Quarks.
Thank you, Tim. That was an incredibly generous introduction, and I'm delighted to be here with all of you. There was a moment when I said to people, I'm coming and I'm talking at Saturday Morning Physics, and they said, they do know what you do, right? So this might be the Saturday Morning Physics with the least physics that you've ever seen, although we're going to have some demos, some really great demos where you're going to get to see some physics. So I'm a historian of the English language. Was thrilled when I was invited to do this. As Tim said, we started talking about this maybe 3 years ago, I think. And here I am. I want to thank everyone in the physics department for organizing this, for all of the tech support here, and to Monica, who's going to be doing the demos today. So, and thank you all for coming. I know there's a lot happening today, and delighted that you are here, both all of you in person and the people who are online. So as a historian of the English language, I study how we got from Beowulf to texting. And we're going to see a little Chaucer later, so I thought I would pull out one of my party tricks, which is Beowulf. So the first lines of Beowulf are What? We gardena in Jerdagum theod kuninga thrum jafrunen hutha athalingus ellen fremeren. So that's English 1,000 years ago. And I study how we got from there to here. I know, wow, that's a long way. And so I also study changes that are going on all around us. We have a few young people here. There is a change happening with if you do something accidentally. Do you do it on accident or by accident? I can mostly see you all, despite the lights. So how many of you say by accident? And who says on accident? Do I have a few young people in here? I've got some on accident people, I see them. This is happening. On average, young people are using on accident. Older people, myself included, are by accident speakers. The thing about language change is that young people on average live longer than older people. And so the on accident speakers are going to outlive the by accident speakers, and on accident is happening. So why, who knows? It could be on purpose, has affected on accident. So I study things like that. I study that must, in the sense of need, is on the decline. I must go to the football game. I must. No, you'd say, I have to go to the football game. I have to run errands. I have to study. So have to is on the rise. Must is on the decline. I know random things like why kernel is spelled with an L and pronounced with an R. I also study things like what happens with sounds, and this is where linguistics gets a little, some of my English majors will say, this feels very sciencey, which it is. The word sandwich, which we do not say sandwich, most of us lose the D, and then something happens for many of us where we don't say sandwich, we say samwich. That N turns into an M. And there's a reason for that. And if you study phonology, you know that it's the nature of the W that changes the N and makes it an M. The same thing happens if you say in between. Say in between quickly. For many of us, that N in between will also start to sound more like an M. In between. Because you're getting ready for that B sound. So this is what I do. Clearly, it is not physics. So what we're going to do today is the talk's got 3 parts. The first is some etymological facts. The second part is the evolution of scientific writing. And the third part, we're going to talk about metaphors, and that's where we're going to get to see some of these demos. So let me grab this. All right. All right, that does not actually appear to be working. I have to turn it on. Well, that would be helpful. I don't know how to turn it. Is that, aha. Okay, so some etymologies. I thought we might start with Saturday morning physics, just for fun, which is why we have Saturn there. So Saturday, if we go back to classical Latin, this is the day of the planet Saturn. So that's Saturday. Morning, now morning is really interesting. Morning, in English we had the word morn, as in it is morn. And you had evening. And evening was formed because you had this verb to even, which meant to come to the close of the day. So that was the verb, and so that moment of the close of the day was called evening. Well, once you had evening, you had morn and evening. Well, that's not very symmetrical. So what happened was people created morning as a synonym of morn so that it would parallel evening. See, this is what's going to happen today. You are just going to get random linguistic facts. This is what I specialize in. And I tell students this. I'm like, this class, you're going to get so many random linguistic facts. And there was one semester where a student who was sitting right about there raised his hand and he said, what kind of, and I said, you can use these at parties. Like when the conversation slows down, you can say, I learned this really interesting fact. And the student raised his hand and he said, what kind of parties do you go to? But it really does work. You can pull out these facts whenever you need them. So that's Saturday, that's morning. So then we've got physics. So physics, actually the first noun we see in English is physic. This is coming in from Latin, a Latin borrowing. And physics meant, it could mean multiple things in English when it comes in. It could mean a medicinal substance. It could mean a healthy habit. Could be physic. The study of the human body, its diseases, and the treatments thereof. And it could also refer to natural science broadly. So here are a couple of quotes. And so the first from Chaucer, we've got from the Canterbury Tales, "With us there was a doctor of physique. In all this world ne was there none him like to spake of physic and of surgery." So this is a doctor of medicine, doctor of physique. Now, I do want to point something out here, which is in Chaucer, that second line, "In all this world, now was there none him like." There wasn't no one like him, right? So you've got a double negative in there, because in Middle English, when Chaucer was writing, double negation was completely standard in English. All varieties of English use double negation. And in fact, in the Renaissance, when the variety that became standardized moved to single negation, we don't have any of those, rather than we don't have none of those, there were people who thought that was a terrible thing, a loss of strength of expression in the English language. So that double negation has a long history in English. And sometimes people will say, well, English lost double negation. No, many, many varieties of English still have double negation. We don't have none of those. That is the grammar of many varieties of English. That construction has a long history. And the idea that those two negatives cancel each other out is ridiculous, because they do not. Right? If I say we don't have none of those, are there any? No. Right? We know this. So, yes, I have heard this joke in a lecture hall where the professor of linguistics says there are no languages where two positives cancel each other out, and someone says, yeah, right. So in the first quote there, you've got physic meaning medicine, and in the second quote from this manuscript in 1330, this is about the 7 arts, 7 liberal arts. And here you've got grammar and music and astronomy and rhetoric and physic. And here physic is probably natural science in general. Physics, we get first cited in 1487. And here are all the spellings of physics that are recorded in the Oxford English Dictionary. And so you will see we've got a lot of K, some CK. I really like the physique with the QU at the end. I think that is lovely, and I think we might have kept that one. But we did not. And by the 1600s, we see physics spelled with just the C become the standardized spelling of that word. And it actually is not until about the early 1700s that physics starts to be used in the very specific sense that we use it now, not for natural science in generally, but very specifically for the natural science concerned with the nature and properties of non-living matter and energy, what chemistry and biology are not doing, what physics is doing. So that's fairly late, 1700s. All right, so that answers the first part of the title. I thought if I put it in the title of the talk, I should answer the question. So when did physics lose its K? By the 1600s. So now let's talk about this word. And let's start with the pronunciation of this word. Tim, you actually looked at me as you said the word. So take a moment and think, do you, as you say this word, because I'm sure you all say this daily, does it rhyme with mark or cork? So I'm going to ask for a show of hands. For how many of you does it rhyme with mark, as in quark? And for how many of you is it quark? Oh, we have a lot of physics people in here. Because this spelling should not sound like quark. This spelling suggests that it's quark in English. Although quart, put a T on the end, and there you get that vowel. So this word is a coinage from Murray Gell-Mann. And from what we can tell, it was an arbitrary formation. And he tells this story in a letter to the Oxford English Dictionary in 1978 about where this came from. So I employed the sound quark. I hope all of you who say quark are feeling very vindicated right now. For several weeks in 1963 before noticing quark in Finnegan's Wake, which I had perused from time to time since it appeared in 1939. The allusion to 3 quarks seemed perfect. I needed an excuse for retaining the pronunciation quark, despite the occurrence of mark, bark, and mark, and so forth in Finnegan's Wake. I found that excuse by supposing that one ingredient of the line, 3 quarks for Muster Mark, was a cry of 3 quarts for Mr. heard in H.C. Earwicker's pub. So that's an allusion within Finnegan's Wake. So here are the lines from Finnegan's Wake. 3 quarks for Muster Mark. Sure, he hasn't got much of a bark, and sure, any he has, it's all beside the mark. So in Finnegan's Wake, it clearly rhymes with mark. But as Gelman says, he needed it to rhyme with quark, and so he had that clever, well, let's imagine it's in the bar, 3 quarks, quarts, as a cheer. Quark here in Finnegan's Wake is, from what we can tell, a reference to like a squawk or a cry from birds. So there are lots of birds in this passage from Finnegan's Wake, and so 3 quarks, 3 sort of caws or squawks from birds. So that's where quark or quark, depending on how you say that word, comes from. Made-up word. There aren't that many in English, actually. It's really hard to make up a word and have everyone start using it. It is easier if you're a scientist and you're describing something that has never been seen before. That is a good way to make up a word and get it used. So here are just a few other very common words in physics to talk about the different kinds of processes we see happening for these scientific terms. So the first 3 here, proton, lepton, hadron, are all coming in from Greek. That ON to signal a subatomic particle, proton first, a lepton small or slender, and a hadron thick or solid. So those are all coming in, as much of our scientific vocabulary does, from Latin and Greek. Then we have electron and neutron, which were actually formed in English for electric plus that ON, or neutral plus that ON. So those were formed within English. Boson is what linguists would call an eponym, so named to honor someone. In this case, Satyendranath Bose. So we get the boson. And then a couple of Latin borrowings, so galaxy, which originally referred to the Milky Way, coming in from Latin, or astronomy, coming in 1275, partly from French and partly from Latin. And I'm going to use that astronomy to actually transition to the second part of this talk about scientific language, because the question that I'm going to ask is, why is the study of stars astronomy? Why isn't it star study? Right? Star is a native Germanic English word, but we don't just study stars, we do astronomy with this borrowed word. And this is true for so much science. So part 2, scientific writing. Why is the study of stars called astronomy? And when did human narratives and the pronoun I fall off in scientific writing? Now, in the abstract for this talk, I had fall out of scientific writing, which is hyperbole. It is an overstatement. And I had colleagues in physics and astronomy say, it didn't totally fall out, which is of course true. You get some first person in scientific writing, but not the way you used to get first person in scientific writing, and I will show you what I mean by that. But we're going to start with scientific vocabulary, because this reveals something fascinating about the way English vocabulary works. English, because of our history, which involves enormous amounts of language contact, has got layers of words in it. So at one layer, we have the Germanic words that have been in English for a really long time. English is a Germanic language, so they've come in. As long as there's been English, these words have been there. Then we've got French borrowings, and these French borrowings largely happened post-1066, Norman conquest. We have a French nobility ruling England, and we have all of this French borrowing in words for law and government and fashion and food. So we've got all of those words, and then, and we've had Latin borrowings throughout history, but especially in the Renaissance, with this interest in classical learning, we get lots of Latin words, Greek, Italian, all of these other words coming in. And I sort of do this because one of the things you see is how these words function differently in English. So if we take that first question, which is warmer, a hug that is cordial or hearty? Okay, can somebody explain how I heard a lot of hearty. How do these two words mean differently for you?
Cordial just sounds polite, and not like an authentic hug, where hearty feels like an authentic hug.
Oh, I love that. So cordial feels polite, and hearty feels like a hug. Like, that's, and I love your arms are like, that's the hug, and the cordial is, you know, it might not even be a hug, right? So a cordial greeting versus a hearty greeting. These two words are cognates in English. They go back to the same root because at the root of cordial is heart. But hearty, heart is the Germanic word. We've had that word in English as long as there's been English. And cordial is a Latinate borrowing coming into English. More formal, less warm. Would you prefer going to a tooth doctor or a dentist? I think I'd rather go to the tooth doctor myself, but this question isn't totally fair. Again, we've got cognates here, tooth and dental, go back to the same root. Doctor, of course, is actually a borrowing. So I'm pretending that tooth doctor is all Germanic, but it's not. Tooth is Germanic, doctor is borrowed. It is actually quite hard to utter even one sentence in English without borrowed words. We have so many borrowed words throughout the vocabulary. The pronoun they is borrowed. That one's borrowed in from Old Norse. So Old Norse, we borrowed they, sky, sister. So we got borrowed words all over the language. So what do I mean by cognate? By cognate, I mean these are words that we can trace back to the same root in Indo-European, the parent language. And what happened was a series of sound changes where you have Latin and Greek, which will keep from what we can tell, the consonant that was in Indo-European. And there was a set of sound changes in Germanic languages, so in English, that will have changed that consonant. So a k in Indo-European, which you'll still see in Latin and Greek, cardiac, cardiology, became h in Germanic, heart. A d in Indo-European, which we keep in the Latin, dental, dentist, became t, so tooth. A p, pedestrian, podiatrist, becomes f in Germanic, so foot. Pedestrian obviously is on foot. This is the science of historical linguistics, is looking at these kinds of sound changes. And what's cool about this is the pattern. And we could spend a lot of time on this, we will not. But, right, so that ka-ha, well, this is why we have horn and cornucopia. This is why we have a hound but canine. Right, so we've got these pairs. Two in English, duo. Clearly also related to two. Father, paternal. It's these sound changes, so the English will have one consonant. The borrowing in from Latin and Greek will have a different one. And you can see the formality distinction, right? A hound versus canine. So one of the examples I love to use is synonyms for ask. Ask is a Germanic word. Question is a French word. Interrogate is a Latin word. Right? So they're synonyms, kind of, right? But interrogating is different from asking, and you can feel the formality of that go up. A home, a mansion, a domicile. English, Germanic, French, Latin. So one of the repercussions of this is what I call the SAT words, the words that we get tested on if you have to take these tests. So here is an example. This is now quite old, but 2011, 2012. Physical exercise often has a effect, releasing emotional tension and refreshing the spirit. You all are good test takers. Okay, I'm getting a lot of cathartic. That would be the right answer. You all did very well on this test. Here is my point. Look at all these. What we get tested on are these words that were borrowed in, often in the Renaissance, as part of the revival of classical learning. The fancy words, the scientific words. This has become so naturalized for us that these are the scientific words that it can be hard to imagine that in the 1600s, there were people who thought these words were a terrible addition to English. They took up too much ink. They were called inkpot terms because they used up too much ink. People said, we don't need these fancy words. We could just use Germanic words, and I thought I would share a few of the possibilities. So for muscles, we could call them flesh strings. A definition could be a say what. I really love that one. Posterity could be afterness. In the afterness, in your afterness. Pentagon, why not call it a 5 square? Foreign could be outborn. And reason or logic could be witcraft. That is my witchcraft. In Beowulf, actually, one of the ways they talk about speaking is that he spoke and he opened his word hoard, which I think would be a great way to say vocabulary. That is my word hoard. All right. One of these great things about English related to this, which is the native English word versus the French borrowing. So we have sheep, that's the Germanic word. It becomes mutton when it hits the table. Look at this little pattern. So pigs become pork, cows become beef. You don't eat cow, you eat beef. Deer become venison, calf become veal, chicken. We do say chicken, but you can also say poultry. This is one of those patterns in English where people will sometimes explain it. This doesn't totally hold, but it's a nice way to remember it, which is you had the French nobility after 1066 in England who was taking care of the animals, English farmers. Who was eating the food, French nobility. And you see this distinction that we have preserved in English between the animal and the food. All right, so now I want to talk just briefly about the evolution of scientific writing to answer the question of what happened to first person, as well as this sort of Latinate terminology that we use. What we see in the evolution of scientific writing is a move from much more person-centered to much more object-centered discourse. And one of the studies that is helpful for this is Dwight Atkinson's book, The Scientific Discourse in Socio-Historical Context. And what he looked at was the philosophical transactions of the Royal Society of London. So the Royal Society, this is where science was happening in London. And it's important to know that philosophy, this title of philosophical transactions, philosophy was actually used to refer to advanced learning or scholarship more generally. So those transactions were scientific. You had a lot of science happening there. The specification in that title, it's not the way we use philosophy today. And scientists, the scientists who were contributing to this journal would not have been called scientists in the early days, because he starts looking at this in 1675. The word scientist is first recorded in English in 1834. So that's fairly late. We have science much earlier coming in from French, but you had people called, they would have been called philosophers, or natural philosophers was a way to talk about what we now would call scientists. So he studies the evolution of writing in this journal. And I just want to share a few excerpts so you can see what has happened with scientific writing. The early scientific writing was often done as letters. Now, it is important to note that these were men. You're about to see a lot of older white men, because that was who was doing science at the time. Men of wealth and privilege who had the means and the time to do science. It wasn't really till the end of the 19th century that we see professional scientists. So here we have Joseph Priestley, famous for the discovery of oxygen, who also wrote a grammar. This made me feel less like an outlier. So here we've got first person in a way that we typically would not see it today. And I'm not going to read the whole quote, but the nitrous acid I have exhibited, and then we see that I'm acquainted with. The more I consider this is to me, right? So we're getting this very first-person discourse that would be unusual for us in scientific writing today. And I wanted to share one of my favorites from physiologist John Hunter. The first experiment was made on 2 carp. They were put into a glass vessel. So there we see that passive that is very now characteristic of scientific writing, with common river water, and the vessel put into the freezing mixture. The water did not freeze fast enough, and therefore to make it freeze sooner, we put in as much cooled snow as to make the whole thick. The snow round the carp melted, we put in more fresh snow, which melted also, and this was repeated several times till we grew tired. I love this. It makes science feel very human, right? So we kept putting in the snow, and then we just got tired. Would be fairly rare to see this in scientific writing today. So here is an example from 1925, where at this point you are seeing many of the characteristics of professional scientific writing now. More passive voice, first of all. So early in 1923, it was shown, and to note, it was shown actually by these authors. So, I mean, they could have said we showed, and I want to emphasize there is plenty of scientific writing that will still do that. But there is, over the course from 1675 to the present, you see a shift away from this first-person narrative toward what can be seen as a more objective, less narrative style. And one of the ways we see this, and again, is, we'll go through this fairly quickly, but more and longer nouns. Science becomes very nouny and less verby. So this is early. This is Isaac Newton, 1675. And I just highlighted here in orange the nouns. Okay? Just visually, I want you to compare this to this sample from 1975. Yeah. Lot of nouns. Part of what happens in scientific discourse when you pull away the first person is that processes, which are usually captured in narrative discourse with a verb, become nouns. So experiment becomes experimentation. Distribute becomes distribution. Demonstrate becomes demonstration. So we take a lot of actions and we turn them into nouns. And that is one of the characteristics of academic writing in general and of scientific writing, is it becomes very, very nominalized or nouny. So just a very short discussion of what happens with scientific writing. Now the third part, what you've been waiting for, we're going to get to do some demos because we're going to talk about metaphors. Now often people think about metaphors as a purely poetic device, and they certainly can be poetic. And if I said her fingers were icicles, that would feel like a poetic metaphor, I think, because we don't hear it every day. We're like, oh, her hands must be cold, her fingers are like icicles. But if I said, I tripped over my words, you might not recognize that as a metaphor. I stumbled while I was speaking. She just ran on and on and on. We talk about speaking as walking or running. That is a metaphor. So we trip, we stumble, people run on sentences. And this is what we're going to talk about here, is these metaphors that can shape the way we talk about things. And so let's start with physics. Here are two prominent metaphors in physics: the space-time fabric and light as a wave and as a particle. And there's some really interesting work about metaphor in science. And one of the arguments is that because the human perceptual system, we struggle to interpret phenomena that are macrocosmic and microcosmic, right? And so one of the ways that we can talk about them and think about them is to turn to our physical experience and to relate it to something that we can see or touch. And that's what you can see with this. So I'm going to turn it over to Monica to do some demonstrations of these two metaphors in physics.
Hello, everybody. So again, thanks for joining you, and thank you, Anne. So to start, we're going to look at the fabric of space-time. And so one of the largest things that humans have studied is the structure of the universe. And so what we have found at that scale is that you can kind of boil it down that mass has an influence on the fabric of space-time. And so this is a very complicated three-dimensional topic, but we were able to produce a two-dimensional analogy to really kind of grasp what's happening on this scale in something that we can relate to. And so it turns out that we can do a fabric of space-time, so we're taking three-dimensional space and turning it into a sheet of space. So there's your fabric. In our case, we have rubber. And if we then take the various objects that are in space and represent them as various masses or balls, we can show that, for instance, if an object is traveling through space without any influence of an object nearby, it should go in a straight line. Pretty straightforward, right? But if we then have that same object travel by something that is very massive, we will see that the mass has an effect on the space around it, and instead of going in a straight line, we now have some effect happen to this object as it passes by this large mass. And so again, it's much more complicated than that, but we can break down that concept in something that's more tangible to you and your everyday life. Okay. In addition to something that is very large, we also have something that's kind of unique, and that is the behavior of light. And so that's where we get into this wave-particle duality. And so to kind of walk you through that, we got to talk about what's a wave and what's a particle. And then let's do an experiment with light and see which one it behaves like. And so over here I have a tank of water. I have a exciter on one side and dampers on the other so that the waves that travel damp out for the most part on this side. I have two exciters. I'm going to start them together, but first I'm going to block one of the channels. So what you're going to see is a single wave travel down, a series of single waves traveling down this tank. And in this first section, I have a separator. And so each of these are going to produce a wave in this first section. And then once you get past here, those two waves, or in this case, because I blocked one, it's only a single wave, you will see the effect of what happens when the chamber is doubled in diameter, or width, and you'll see that the initial wave that comes through is about a height of our high wave. And once it passed the separator, it's double the width, therefore the height cuts in half. If I then take a second wave and let them constructively interfere, you'll see that they are the exact same wave here, and then when I double the width, you'll see that they actually add together, so those two half waves add together to give you that same wave on the other side. And so that is constructive interference. So that is a property of the waves. Now if I then make it so these waves are out of phase with each other, let's see them interfere now. You'll see here, they're going opposite directions, but as soon as they pass that barrier, it's essentially canceled out. And so that is destructive interference. And so these are properties of waves that we see in water, but also in other places. Since this is a linguistics talk, we got to bring in sound, right? And so first, I've got two speakers, and I've got our function generator. It's going to produce a sound. Right now, I have disconnected one set of the speakers, so we are now just going to hear sound out of a single speaker. What I'm going to ask you to do is you're going to close one ear, and you're going to move in 3 dimensions. So you can go left, right, up, down, forward, back, so whatever's comfortable for you. And what I want you to observe is the sound that comes from a single speaker. All right? So here we go. And you want to move kind of slow. So hopefully you don't hear anything. You just hear the sound, right? All right. So now I'm going to take 2 waves, because sound are waves, and I'm going to let them interfere with each other. So I want you to do the same action and do it kind of slow, and I want you to hear the difference. All right. So hopefully what you have heard was just like what was happening with the water waves, areas where it was quiet and areas where it was extra loud. And so that's, again, interference of waves in another medium.
And
now,
Monica, I just want to say that was so cool to watch everybody just be like,
they
were a little wave going on out there.
And so now the question is light a particle or a wave? Well, if light was a particle, I have here a very crude set of slits. If you are familiar with the experiment of the double slit experiment, this is where they found the behavior, or studied the behavior of light. And so the idea is if light was a particle, what would it look like if it passed through 2 slits? And so from above, you will see I have some water. I'm just going to spray it out the end of the nozzle, and each water droplet is essentially a particle. And we're going to let it pass through the slits. And so let's see what happens. Oh, got to prime it first. Okay. Okay, so now if I lift it up, you'll see that essentially 2 spots formed. And so if light were to act like a particle, it should be 2 blobs on the other side of the slit. Well, let's see what light acts like, shall we?
We shall.
And so what I have here is the equivalent. I have a slit, but they're much, much closer together because the size of light particles are much smaller than the size of the water droplets. So you have to have a smaller slit. And then if I go ahead and turn it on, you will see that those 2 slits do not form 2 piles of light, but actually an interference pattern. So you're getting at each of those slits 2 waves that come out and together on the plate interfere just like the sound waves did when you moved left and right. You're going between the bright spot and the dark spot, and the bright spot and the dark spot. And that is in 3 dimensions. We are just looking at it in a 2-dimensional snapshot. And so that is wave-particle duality. All right, and that's
Monica, thank you. I was so thrilled that we could do those experiments. And I know the first one, or the one with light as a particle, you were going to do with spray paint, right? But we didn't actually want you all to have to smell that for the rest of the talk, so a very creative solution to that. But a way to show these metaphors that we use in physics And sometimes people say, well, you shouldn't use metaphors in physics. We use metaphors all over science, and we use them all over our language. And so I want to show you what I mean by that. This is what linguists would call conceptual metaphors. These big structuring metaphors, like talking or speaking is like walking or running. This is pulling from work by George Lakoff and Mark Johnson in a book, the first book in the late 1970s, Metaphors We Live By. And here is an incredibly common one. Treating an illness is fighting a battle. This is so naturalized that when I teach this here at the University of Michigan, the students say, no, but it is fighting a battle. And I say, no, that is a metaphor. And they say, no, it is a battle. Can people just throw out a few examples of this?
Well, in sports too.
Say it again?
In sports too, you're killing somebody.
Well, yes. So you also get battle metaphors in sports. And there are some newspapers and magazines that have tried to move away from that, of, that team got slaughtered. Right? No. But so in medicine, what are some examples of, this is the big conceptual metaphor of treating an illness is like fighting a battle. Once they start, you'll...
Like
conquering a disease. I'm building up my defenses. War on cancer. I've got a whole list here. We fight off or battle with disease. The disease is the enemy. We build up our defenses. We defeat or beat a disease. We kill a virus. Diseases invade or attack. Treatments are weapons, and we target diseases. We treat them aggressively. We have killer T cells, painkillers, wiping out smallpox, infiltrating carcinomas. The body is a battleground under siege. Armies of T cells patrols, foreign intruders, diseases that batter the body, maybe the body's shield or armor, skirmishes with diseases, the body becomes defenseless. I highlight this not to criticize it, but to say it's a metaphor. It's a big conceptual metaphor. And it is so naturalized, it can be hard to think of another way. Well, how else would you talk about it? And that's actually a challenge I've sometimes given to students of, what if the whole metaphor was about our body is hosting an unwelcome guest, right? Or cleaning, right? And we're like, oh, but that feels so fake. But it's because it's not a naturalized metaphor for us. There has been some work on this metaphor. Susan Sontag actually wrote a compelling book called Illness as Metaphor. This metaphor of treating a disease is fighting a battle can be extremely helpful for people. It can be a way to get money, right? To say this is a war on cancer and it's a way to raise money. It can also be there are patients who find it very empowering as a way to think about this. But it can also, and it's important to point out that there are patients who don't find this metaphor helpful, who say, what, if I lose, it's because I didn't fight hard enough? Like, that's not my experience. Or I will say, when my own mother was dying from a very long, prolonged disease, and my father would be like, you have to fight this. And she said, I don't want to spend my last time fighting. That's not how I want to do this, right? So you could just see this metaphor making sense to some people and not to others. And that can be why it's important to highlight these sorts of metaphors. So let me show you some others here. Now you're going to go out in the world and see these everywhere, because they are everywhere. So understanding is seeing. I see. You don't see. You understand. Your ideas are unclear. They are opaque to me. Oh, now it is transparent, right? No. It's all a metaphor. but so naturalized that at this point, see does mean understand for us. Learning is eating. There are some unfortunate consequences of this conceptual metaphor. So we consume ideas. And then I think an unfortunate practice can be regurgitating them on an exam. Right? But I find that idea hard to swallow. Let me chew on that for a little while. But often what these are doing is taking abstract ideas and bringing them to our physical bodily experience. Life is a journey. Oh, you hate this.
I hate when people say, I'm so glad you joined me on this journey when it's about something they're doing mentally.
Uh-huh.
Okay, that is not a journey.
Okay, so she said, I don't like it when people say, join me on this journey. It's not a journey, but we sure talk about it as a journey. Can you give me some examples? Say it again. Tripping? Absolutely.
Life is a highway.
Life is a highway.
Road to life.
Road to life, the road ahead.
Walking a set path.
I'm walking a set path. What path, right? A path. I'm taking a path. And what direction am I moving? Forward. Right? Okay, we're in a physics lecture. The future is not actually in front of us. But we think about it in front of us, and one argument is that because our eyes look forward, we think about the future. Imagine if you were a crab, right? But interestingly, you could think about the future as being behind you and the past being in front of you because you can see the past, but you can't see the future. So maybe it's behind you. You're like, no, it's in front of you. Right? Because we talk about things in particular ways. I still have more. Time is money. And I know people will say that as an expression, time is money, but think about the way we talk about time. Spending time, wasting time, borrowing time. Could I borrow a few minutes? Because you're going to give them back? No. But we talk about time in this way. We talk about good as up. It lifts my spirits. I'm buoyed. I'm depressed. I'm down. You're like, but my body does that. It's a metaphor. And then this is, argument is war is one of the most famous metaphors in the book, metaphors we live by, of the way we talk about arguing. So going on offense and defense, shooting down other people's arguments, that we have a lot of, again, very military language around arguments. None of this is to say we shouldn't do this. It is to say it's really good to highlight the ways that these metaphors get naturalized in the language. One of the questions that I can anticipate is people say, well, does it determine the way we think about things? And this is a very controversial question in linguistics, which I can't totally do justice to here, but this relationship of language and thought. So if you talk about this in a particular way, does it mean you think about it in a particular way? Here's one way to think about this, and that I have found very helpful, which is to separate out habitual thought from reflective thought. Habitual thought, I think, I would be willing to argue that our language can habituate us to thinking about things in particular ways. That because we talk about it that way, it sort of puts a groove in our brain, and we often think about it that way. But upon reflection, we can think about it another way. So our language primes us to notice particular things or think about things in particular ways, but it's not that it determines that we have to think about it that way. If we step back and say, oh, that's a metaphor, or there are other colors beyond the ones that my language names, and I can think about those. that there's much we can do with reflective thought, but that it is worth thinking about the things that our language habituates us, and those sorts of patterns. So, because when I was doing some of the reading about metaphors in science, you occasionally see people taking the strong position of, well, therefore we shouldn't use metaphors in science because they aren't true. I think metaphors in science can be very helpful. First of all, they're a great way to explain things and teach people things. And when we're trying to talk about things that are either too small or too big for us to perceive with our own eyes, it can be a helpful way to try to understand them. It is also helpful to recognize that they are metaphors. And so I really appreciate Monica doing this sort of let's look at these scientific metaphors. Is space-time fabric? No, but can we learn things and understand it in a way by thinking about it as fabric? Sure. And that's a way, I think, to take a sort of more nuanced position about how to think about the good work that metaphors do and also the fact that they are metaphors. So with that, I am going to close this talk on physics and language. And I hope that I have shown you some interesting connections among them. And most importantly, I hope I have given you some interesting random facts that you can take to your tailgate or to your next party and say, when the conversation gets quiet, you know, I was in Saturday morning physics and I learned about pigs and pork. So thank you all for being here.
Thanks so much, Anne. That was amazing. And we will have time for our question and answer period now. We'll give a minute or two for people who want to get to their tailgate. And if that's really on the back end of a truck, then it's not a metaphor, right? We have a microphone set up here for those who want to ask questions. And I'm also looking for questions from online. I do have to say, even though we use language a lot, I really feel like I'm out of my element here right now.
Well done.
Trying to connect. All right. Well, I'm going to, I guess I'm going to start.
Okay.
Because this is another one I've been waiting to ask for quite a while. And it was actually stimulated by listening to one of your radio segments. And that is, data are,
oh.
and actually, data or data. And I do have to say, when you put up the question about how to pronounce Q-U-A-R-K, I couldn't think it through because I just say it instead of trying to imagine how I would say it. So I don't know how many or how often you all use the word quark, but I use it fairly frequently, so I don't think about it. Does that happen too?
Well, yeah, so I was just thinking when you said, I just say the word, I don't think about it. Welcome to my life. And there are times when I'm studying something and I get to the point where I'm like, I don't know what this word means to me anymore or how I say it because it all starts to feel weird. The question of data, is it singular or plural? I was actually at one point, this is maybe 10 or 15 years ago, I got an email from a department that will remain nameless but was not physics because the department listserv had exploded in an argument about whether data was singular or plural, and I was brought in as the referee on this argument in a department about whether data is singular or plural. So should it be the data shows us or the data show us? And the answer is right now in English, it is both of those things. This word borrowed in from Latin, and in Latin, data is plural. Datum is singular, a word I know you use every day. and data, which is plural. But what happens is that once a word comes into English, it is English, and we get to do whatever we want with it. And what has happened to data is that it has come to work like information, as in a collective noun. And you would say the information is, or the information shows, even though the information, there's lots of information, which means that when we talk about information, we actually have to have a piece of information. We have to have another quantifier because we can't say an information. So we have to have a piece of information, a bit of information in order to count it. Data is functioning as a collective for many of us, but not for all of us. I was on a podcast with Adam Grant. He actually cut this part out. He got so mad at me that I said data can be singular, and he said, no, it can't. It doesn't make any sense. And I said, it makes total sense. It works just like information. What I try to do as an editor is say, right now in English, just be consistent. If you're using it as plural in an article, use it as plural all the way through. And if you're using it as singular, use it as singular all the way through. It doesn't actually matter. And if I had to bet, I'd make these bets. The singular is going to win on this. So if you want to get on the winning bandwagon, I would get on the singular bandwagon. I would just sort of go there.
It's a really interesting data point. Question?
Yes. Does this thing hear me okay? Okay.
Yeah.
Great talk. You got me thinking a lot about disease as a metaphor for war. And as somebody that actually comes from biophysics and actually gets to see these outcomes from patients a lot, I still find it hard to believe that we actually take it as a metaphor because, I mean, oftentimes you see diseases progress a lot like battles, and sometimes battles progress a lot like diseases as well. And now it's making me think, is it too much to say that language in and of itself is a metaphor for what we see in life? Or, I don't know, how would you like to see that? How do you see it?
Oh, what an interesting, okay, well.
I can clarify it if you'd like.
Well, stay there, because I may need you to clarify it. But, I mean, the first part of, there's a reason that the metaphor is so powerful, is that, yes, you can find all of these similarities. And there are ways in which treating a disease is not like fighting a battle, right? I mean, there's a way in which when we talk about viruses, they are also part of the natural world, right? I mean, and so trying to, and things that we sometimes will talk about killing in medicine, we don't actually kill. They can no longer harm us, but they're actually still technically alive. So there are ways that it actually can mask things that the metaphor itself is not entirely accurate. But there's a reason it's powerful, because we can see those analogies. Do I think there are all kinds of metaphorical properties of language? Language is a way that we can talk about the world, and metaphor is one of the ways that we talk about the world. So I don't know if that helps with your question, but it's one of the, I'm glad it has you thinking, because I remember when I first read that book, Metaphors We Live By, and to suddenly realize all the things we talk about metaphorically, because how else do you talk about abstract things? You need to relate them to things that we know in our physical experience. It gives us a way to talk about them. So thank you for being here, and thanks for the question.
You don't think the medical ones came from psychiatry to make it easier for patients? You don't think the medical terms that we use as metaphors, or the metaphors for medical treatment, came from psychiatrists to make it easier on the patient?
Well, I think they can make it easier on the patient. I also think, and when I started reading about these metaphors in particular, it was interesting to read from patients who find it very empowering and helpful, and patients who don't. And that
It felt warmer. instead of feeling as cold as the scientific reasoning that doctors use, or the language they use, that it felt more humanized.
So the argument that the metaphor feels more humanized. And the metaphor, it's one of the things metaphors do is make it feel more humanized. But whether battles are warmer, I think that that would be a real question for us to grapple with. In the same way, and you brought up sports, right? I mean, that talking about sports as battles or wars, I think that's worth, and I was glad to see some publications sort of raise questions about, do we really want to use this kind of violent language to talk about winning and losing a game, right?
Just here's a question that follows up on metaphor. So to a linguist, does a metaphor eventually become not a metaphor?
Right. Yes and no. And the yes part is important. When you look at how words change over time and how their meanings change over time, one of the processes of semantic change is metaphorical extension. So you see a word come to be used figuratively or metaphorically, and it sort of takes on that meaning. You'll hear about this on the radio in a couple weeks, but I was just looking at the word bloodletting, which was, of course, a medical practice of getting rid of excess blood. But it has come to be used metaphorically to talk about things like layoffs, right? Bloodletting on Wall Street. This happens with words all the time, is that they get metaphorical extensions. Or let's think about a mouse on a computer, right? I mean, that's taking the word mouse and then being like, oh, this little thing that we scoot around is like a mouse. So we'll get how it used to have a tail, right? Does mouse now mean that little computer? Yes, accessory, it does. So at some level, that is now the meaning of mouse. But we can also, on reflective thought, say, oh, that was a metaphorical extension that got us there. If you look in dictionaries, I think most of them, if you look under see, it will say to understand, because that is now a meaning of see. But we can also see the metaphor that is there. So the answer is yes and no, or yes and yes, or
I see.
something. I see, I know.
Actually, when one has two of those computer things that you...
I know, what are
I've
they?
never been able to figure that
What
one
are
out.
they? Are they mice or mouses? Right. It is one of the strange things about some of those metaphors.
Maybe it's two mouse. Question.
Thank you for doing this. So my question is about, it's a big question, but it starts with words and naming things. So I heard a story on a podcast years ago about how the color blue for certain people many years ago, thousands of years ago, it doesn't exist to them because it doesn't have a name. So if you were to ask certain people what color is the sky, in their language they wouldn't say blue, they would say white or gray or something because, and this is my question, if something doesn't have a name, it doesn't exist to me. Do you have any comments on this much larger than, I mean, it's not really a linguistic question, really, it's a much bigger question about meaning, I guess, but any comments or have you encountered that?
Yeah, Tim and I were talking before, I always wanted about staying in one's lane. This is a huge question in philosophy, linguistics, cognitive work. What is this relationship of language and thought? You certainly hear people talk about the experience of not having a word for something, and so having trouble thinking about it, and then having a word for it, and that opening up doors. And I'm thinking of some really powerful examples that they've done with, for example, deaf children in places like Nicaragua, where many of those children were deprived of language for much of their childhood, and then were allowed to learn sign language. And they talk about it opening up their thinking to have signs for things. So you hear these of sort of once I had a way to talk about something, it opened up worlds. And they actually use that sort of language. It opened up worlds for me. At the same time, I am very reluctant to say the human brain can't think about things that we don't have language for. Because, and this is where I get into the habitual versus reflective thought. That when we're introduced to new things, we find ways to think about them and ways to talk about them. So I hear that when people say the way that you might describe the sky, if you don't have the color blue, you might describe it in some other way, and you might see it slightly differently. But I don't want to take as strong a position as if we don't have language for it, we can't think about it.
Great talk, thanks. I am wondering what effect AI is having upon the language thus far, and what you predict in the near future.
Whew. You all do not mess around with your questions. Okay, I have no idea. Let's start with that. What is AI doing to language? What is going to happen here? This is moving, as we all know, so fast. What AI could do 2 weeks ago and what AI can do today are different things. I'm exhausted. I cannot keep up. It is getting better and better at sounding human. It still doesn't sound fully human, but you can feel the programmers getting better at disfluencies, for example. So if you're a human, when you speak, you have lots of disfluencies. Ums and uhs and pauses, and you start a word and you stop. Well, they are getting AI to do more and more of this. So it is sounding more and more human, because when that doesn't happen, you heard me, we start and stop. When AI doesn't do that, it doesn't sound fully human. I do want to separate the written language from the spoken language, because the history of those have been different throughout the history of the language. There are patterns to AI writing that we're seeing develop that I think, if you study the history of writing, you're going to see the AI effect on writing. My friends who are more expert in this than I am are pointing out to me that something interesting is happening now, because things like generative AI is now feeding on its own products. So I'm not entirely sure what that's going to mean, but it was feeding on human-made products, but now there's enough stuff that's been generated by generative AI that's the input, which is changing the average of kind of what it's doing. So it's not clear to me I don't think we have linear change here that as AI is doing this. People are starting to say that there are words that AI uses a lot that they're hearing humans use more, which would be unsurprising because, words can be in music or TV and they will suddenly become fashionable. And I think AI has the ability to make words fashionable in ways that we will see. But that's just a few thoughts. I don't totally know what's going to happen here. I think about it as a linguist. I think about it as a teacher, as I'm sure you do as well. I think about it as a scholar. This is a fascinating time.
I was thinking that if AI learned from human intellectual history, basically, right? Everything that large language, and then is learning from AI, it's sort of going to stop, right? Because it's learning from the same dictionary, so to speak, and not being creative. But at least a year ago, we found AI making lots of mistakes. It had to have an answer, and it seemed to make stuff up. So
yes.
It may actually grow in the realm of falsehood, so to speak.
Right. Well, and a friend of mine recently was asking one of these generative AI programs a question that she knew a lot about. spat out an answer that was not true. She said, "That's not true." And it was like, "Oh, yeah, sorry about that. That's not true." Like, so, we can also call it out on its falsehoods. But it was a very, as she and I were talking about it, it was a very believable thing that it said, that if you did not have expertise, you would have believed the AI. But as soon as you called the AI out on it, it was like, "Oh, yeah, I made that." I think what it said is, "Oh, yeah, I made that up." Excellent.
I have an online question, actually. How does the science metaphor in English get translated and used in other languages? So if there's a science metaphor in English, how does it get borrowed, maybe, by other languages?
Yeah, so...
Is it a literal, I'll just continue, is it a literal translation, or might the metaphor change in the non-English language, the meaning of it?
Well, so what I can say in response to that is that different languages, there are some conceptual metaphors that you'll see across languages and some that will be language specific. And that, again, is a nice way to denaturalize those conceptual metaphors, is that there are languages that will use different metaphors to structure the way they talk about something. So they're not inevitable, but there are also ones that cross languages, in part because, as I mentioned, some of the ways those metaphors work is that they are capturing our human experience. So, for example, more is up, right? More of anything is up. Well, that's because in our physical experience, if I'm stacking up rocks, the pile gets bigger. And so I think about more as up. But not all things that are more go up, but I tend to think of more as up because that's my physical experience of the world, of having more things. And that's one that you will, because that's going to be part of human experience across languages, you'll see.
So I was thinking of two questions, and I decided rather than the philosophical one, I'd ask you one more that was about language. When you talked about physics, my mind kept popping when you talked about the medical part to physician. And I was just wondering, with the physicist-physician branching, was that war? Or, I mean, how does that come about?
I don't know that there was a war there, but you're noticing we've got the same root there of physician, physical, physics, that those are all going to be cognate words in English. And that's where I think it's helpful to realize the really broad meaning of physics when it first comes into the language, that it's not until the 1700s it specifies to what we do at Saturday morning physics, except for today. And so, and the study of the physical world. So the study of the natural world was all physics. Yeah.
Well, I was thinking about one of the limitations of language, and it seems to me that in language we are trying to convey something that we have formulated in our minds. And that idea, if I can call it that, doesn't have a geometry at all. It doesn't have a shape. It's sort of disembodied. And when we try to communicate it in language, we chop it up into words which are particulate. So where do you go from there?
Well, again, this is why we have whole classes on philosophy and language. And, the question of, if I understand you correctly, you're asking about this relationship of language and thought, and the question of, is the thought already there? And then language is just the way we express the thought. We chop it up into words and we put it out there. And the fact that I have learned this language that has categories in it, and language is part of my cognition, which it clearly is. Do the categories that my language give me affect the way I perceive and think about the world? Because it is actually part of my cognition. And I think the answer is probably both of those things, right? And that's where it's this, that I don't think that the way our language categorizes the world entirely determines the way we think about experience it, but it is part of how we experience it. Because fundamentally it's part of our cognition. So how much of the thought is out there that then gets funneled into language, that's this part of philosophy that people have been struggling with for centuries, actually. And it's a great question, and I'm delighted to see you all picking it up here.
Actually, I don't know if this is a question or a comment, but it relates back to the question about physics. And also we eat in French and the animals are named in German.
Yeah.
So science words like physics and chemistry and I'm not sure about biology are common across many language roots like French, German, even Arabic and Hungarian, my heritage. So they all use physics in some sense. But seems to be the case for the hard sciences, we might say. But economics, for example, or history are quite different in French, for example, and German. Do you know why that is?
Well, I always want to be careful about what I do off the top of my head and not off the top of my head. But one of the things about scientific vocabulary, and we'd want to look across those languages, as I showed you all, English actually borrowed in from Latin, Greek, and French many of our scientific terms. So the fact that you also see those in Romance languages is because English borrowed them in to do the scientific work. And the reason for that, this can be hard to imagine right now, but English around 1500 was seen as a rude, crude, unworthy language. It would have been hard to imagine it as a world language. It was seen as unable to handle most of science or literature or anything that needed ornate language, it was a third-rate language compared with Latin and French. Those were the high languages, and science and law were done in those languages. And then during the Renaissance, one of the efforts was to embellish English, to make it more ornate, so that it could actually do science and high literature. And that's why this is why the Renaissance sees thousands of borrowings, is to make English rich enough and ornate enough to do this work. And as I described, there was also the backlash of we don't need all these fancy words. We could do science without it. But the idea was actually English needed to borrow to do that. Subsequently, as English has become the language of the international language of some science, you will see English being pulled into other languages because English is the language of technology, and a lot of science. And so languages will pull in the same way that English pulled from other languages, including Arabic, to do science. You will now see other languages sometimes pull from English to do science and technology. That this is how languages borrow from each other. This is where languages do not behave. Sometimes you'll see those kind of family tree models of languages, and the way that languages can borrow words does not work well with that analogy. And borrowing is an interesting term because languages rarely give the words back. Right? So how we want to, sharing, stealing, but the other language doesn't lose it, right? So it is a kind of sharing across the languages. Yeah.
I kind of had 3 short questions, but if that's too much, I can leave it off. So the first question is, I guess, the most relevant. When you talked about all the different spellings of physics and how it sort of changed over the ages, but we ended up with just the one spelling of physics. How does that get chosen? Is it just whatever's used the most, or did certain people use that and it became more popular?
Okay, that is a great question, and I'm so glad you asked it, because this is an interesting, again, as we think about human cognition as well. In Old English and Middle English, certainly in Middle English, you see a lot of spelling variation, including in the same text. So the word might, M-I-G-H-T, there are dozens of spellings of that word. And you will see a scribe use different spellings in the same text, which to a modern eye, we're like, how could you not notice that you were spelling that word multiple ways in the same text? Well, here's how you could not notice, I think. The analogy I use, so my handwriting is a funny mix of print and cursive. Okay, right? For those of us who learned cursive and print, so now mine is just this whole mishmash, which means that when I, for example, write on the board, I have like a script F and a print F. And sometimes I can use both of them in the same word. I have a print S and a script S. And I usually try the day I talk about this in class to have on the board some of that variation. And I say to the students, have you ever noticed that I have 2 S's and 2 F's? And they're like, I have never noticed that. Because their brains just process them as 2 variants of F. And so I use that to say, like in Middle English, sure, it was M-Y-G-H-T, M-I-G-H-T, M-I-C-H-T. I knew it was might. My brain just processed it all as might. I didn't worry about the variation. So that was sort of how spelling variation worked, was that the brain just recognized the word, the variation wasn't important. Standardization, which starts to happen in English in the 1500s, 1600s, is most successful with spelling, and standardization is about having 1 spelling. So we occasionally allow 2 still, but for the most part, as we standardize spelling, we move toward 1 spelling, and that will be seen as the standard spelling, and physics didn't get a K. And how we pick that one is usually the preferred, who was running the printing press? What does the AP style guide prefer, right? That's how we get what the spelling is. It's usually not a linguistic reason. And I'll give you one last random fact here, which is around spelling, so we've got, right, standard spellings in Britain and the US that are different. So honor has an O-U-R in Britain, O-R here. Theater, R-E versus E-R. We have 1 person to thank for that, and that is Noah Webster. That Noah Webster, and this is pretty rare, but you're sort of like, why? Well, in this case, Noah Webster, because he saw his dictionary as a fundamentally patriotic project. It was a dictionary of the American language, and Americans were going to have their own spelling, because that was how we were declaring independence, was to have our own spelling. And so he actually changed some of those British spellings and said Americans will spell it this way, and that got picked up by the government printing office, and that's why we spell it that way in the US and a different way in Britain. Though he had some reforms that actually didn't make it. I think soup, he wanted like S-O-O-P, and people were like, nah.
I guess American English needed to have more uses for the letter Z or Z.
Thank you.
One more question, Juno, and then...
Yeah, I won't go through all of them.
Yeah, because we got some person behind.
Right. I guess something I wanted to mention, I don't know if you've heard of this text called Uncleftish Beholdings, but it's just something I was thinking about. It's a short text that's basically a paper on atomic theory that was specifically written to only have Germanic
I have
English
heard,
words.
yes, thank you. Yes, to only have Germanic. It's hard work.
Yeah, it's very difficult to understand as an English speaker. I thought that would be sort of relevant to your talk.
Yes, thank you for reminding me of that. It's been a long time since I looked at that.
And one last question, if that's okay.
Yeah.
The wave particle thing got me thinking a lot because obviously one of the big realizations that we had 100 years ago is that there's not a difference between waves and particles, and so fighting about which one light is, it was like a misunderstanding, and then we realized. So does that apply with like the other metaphors too? Like, do doctors that use more war language, are they more aggressive in their treatments or something like that?
Yeah, I don't know that anyone has ever tried to study that, but it is, I think you've given us a really nice place to wrap up, which is I think it is one of the reasons why we should be aware of the metaphors we're using, is we can use them as a way to understand something and a way to talk about it, but they both reveal and they obscure. And so to be aware of what they're doing to make sure that we take the good and we're really careful about the ways in which they can obscure or cause us to do something that might not be the right way to treat an illness or that kind of thing. So thank you all for staying. I hope you have a great rest of your Saturday.